Nu, ko, mums nākamā prezentācija pēc programmas ir visnotaļ sensitīva tēma. Ir Zoltūdes case. Un, par ko ir šī prezentācija, kas tūlīt sekos? Šodien Latvijā ir eksperti no Vācijas, kuri ieradušies arī tādēļ, lai uzstātos šeit šodien, pastāstītu par ugunsgrēku trauksmes sistēmas aktivēšanās gaitu tajā dienā, liktenīgajā dienā. Un tā īstenībā ir vienīgā ekspertīze, kas ir veikta tieši par ugunsdrošības signalizācijas nostrādāšanu tajā dienā. Iepriekš šīs ekspertīzes rezultāti nav tikti publiskoti, un, lai viss būtu arī korekti, ir jāpasaka, ka ekspertīze ir veikta pēc Maksima Latvija pasūtījuma. Par ekspertu kompetenci un neatkarību jums nebūtu jāšaubās, jo tie ir eksperti no Vācijas, tad ne no šī tuvā loka mūsu mazā dīķa. Tad viens no ekspertiem ir no kompānijas Kofler Energies, kas ir vadošais inženierijas uzņēmums enerģijas un resursu efektivitātes jomā Vācijā ar 40 gadu pieredzi. Un otrs eksperts ir no kompānijas CRP, kas ir vadošais uzņēmums profesionālās konstrukcija ekspertīzes jomā Vācijā ar 25 gadu projektu pieredzi. Prezentācijas laikā eksperti iepazīstinās ar to, kāda bija ugunsdrošības signalizācijas sistēma Priedaines ielā 20, kā tā darbojās. Tiks parādīta arī notikuma chronoloģija 21. novembrī 2013. gadā. Tiks runāts par to, par signalizācijas noskanēšanas iespējamiem iemesliem, un tās būs Vācijas ekspertu izvirzītās hipotēzes, kā arī viņi apskatīs signalizācijas iespējamo sasaisti ar jumta iebrukšanu. Un tiks dot arī ekspertu secinājumi. So, gentlemen, the floor is yours.
Thank you very much.
We expect, I promised a lot of things that would be explained according to what we discussed. And after the presentations, you're invited to ask questions. We don't have time for many questions, but if there will be some, we'll definitely do that. All right?
Okay. Thank you very much, Oskar. And thank you to our client who invited us and gives us the opportunity to present the main results of our expertise concerning the activation of the fire life safety systems and the discussions if there had been any interconnection with the collapse of the roof on Priedaines Street 20. That was the question that we got to investigate. And the main result is that there was no connection between the fire alarm and the roof collapse. And to show you how the result was gained, first, I show you which kind of fire life systems are or were implemented inside this building complex. Afterwards, I give you a short overview of what happened this day on 21st November in 2013. Afterwards, and the third, we are showing you what is the most probably reason for the false fire alarm there was at this building complex. And then my colleague, Mr. Fuhrt, shows you why the roof collapsed indeed. And then we are still discussing with you the points, the hypotheses and the speculations, hadn't there been any correlation to or not. To give you a short overview, it's important to know how the building is divided. We have here on the violet part the residential building. This residential building started at the second floor. And beneath there were the back offices in the first floor of the supermarket. And beneath in the underground, all the technical rooms, not all, but pretty all technical rooms for the supplying of the building complex. On the left side, the blue one, this was the shopping center where the roof collapsed. We've got here on the left the entrance where the security was located. And down there in the basement, there was the underground parking. This part, the residential building, and the part of the underground here were still in full function, even after the collapse of the roof. And we were able to investigate it on site. There's a cross-cutting to show you more, to explain a little bit more for you how the building itself works. So what kind of fire life systems we have here? First of all, we've got a fire detection system with its fire control panel. That's the red one. Then we've got an automatic voice alarm system. That's the green one. A smoke exhaustion system to bring out smoke. That's the violet one. And then, last not least, there is a firefighting system. So, with fire hoses and sprinklers. The fire detecting system, one part are manual detectors with push buttons, which are mounted and located at entrances and evacuation doors. If someone locates a fire, then he presses the push button and the fire alarm goes strictly to the fire control panel, and that is absolutely in the second mode. Besides this, there are smoke detectors. These are automatic detectors. If there is smoke somewhere in the building, then they are detecting this smoke, and they give a fire alarm. These are pointal smoke detectors, and they were mounted under the roof of the supermarket in the first floor, and in the back office on the right side, in the first floor, and in some parts of the second floor under the residential building. That's a picture of the control panel, and this was installed at Priedaines Str 20. It shows messages to the user where exactly the fire is detected. Which smoke detector, which line, which room. Or if it comes from a sprinkler system, then it shows sprinkler system, there's a fire alarm, and so if someone looks at here, he can locate where the problem is. What is the normal sequence of such a system? First of all, it's in standby mode. When a fire alarm is coming, then it goes normally in the first fire alarm mode. The system itself checks within 12 seconds if there is a technical false alarm. And if not, if the time is exceeded, it goes in full alarm mode, means the second fire alarm step. At this point, a fire alarm can only be quit by a person who is authorized in the second level of the fire control panel to bring it back. But of course, if there would be a real problem, then the fire alarm would come again. If the fire alarm system is in full mode, then the automatic voice alarm system will go on inform people who are in the building, and the smoke exhaustion system is going on. Normal ventilation system is going off to avoid turbulence, because in this case, smoke could be brought down by ventilators, so they are switched off. That's the automatic voice notification system. It's with loudspeakers. They were installed in the first floor and in the back office, where they informed people. The smoke exhaustion system consists of fans mounted on the roof to bring out smoke if there would be some. Coming to the firefighting system. We've got here two parts, manual ones. Besides normal known fire extinguishers, which are placed perhaps here on this side, there are fire hoses, which are placed in cabinets. These cabinets, you can see here in the hotel too, are normally locked by a key. And to open it, you need to push down a window and put out the key. That's the normal fact. And then you can manually fight the fire. These fire hoses were placed for the us interesting part as well in the first floor, as well in the basement and the underground. And they were supplied by a pipe which is mounted under the ceiling between underground and first floor. That's important to know because there is no direct connection with the roof. Backwards. Sprinklers were installed too, as well in the underground, as well in the first floor. We've got here two types of sprinklers. One is a wet system, means water is inside the pipe. Another one is the dry one. It's concerning the sprinklers in the underground. Why are they dry? Because in underground parking, there could be perhaps, normally not, but it could be temperatures which would cause freezing if there would be water inside the pipes. That's how the firefighting system is designed in Priedaines Str 20. We've got here on the left side the pump station in the basement, from where the supplying of all systems came from, with an electric pump, and in case there would be a problem with the electricity power, there's a second supply, it's a diesel pump. From there, we've got 7 lines went off inside the building. Line 1 and 2 were for fire hoses in the residential building, which was still under construction at this time. Line 3 and 4, the wet systems, were for the sprinklers in the first floor. These pipes were mounted under the roof and under the ceiling between first floor and second floor, concerning the part of the residential building. Then we've got line 5 and 6. That was a ring system for fire hoses in the commercial part of this building. And as I already told you, these pipes were mounted under the ceiling between basement and first floor. And line 7, these pipes were mounted too under the ceiling of the basement. It's for the sprinklers. So, what happened on 21st November 2013 concerning the fire alarm system? At 1621, a fire alarm was caused by the sprinkler system. By the pumps, came from the pump station, not from the sprinkler system, but came from this pump station. And it caused a fire alarm inside the building. It could be located, comes from down, from the basement. Line 6, which is located for the system in the basement. There's a signal, the valve is open. Because the valve is open, the contact was lost and it came to a fire alarm. And because of this, the automatic voice alarm system went on. The smoke exhaustion system went on, and the normal ventilation went off. Oops. But there wasn't any fire inside the building, though it had to be a false alarm. And the security attempted to reset the fire control panel several times. Normally it would work, but in case of the pump station, it doesn't work because the valve is still open. So the alarm is already existing. Even if you are exciting the fire alarm mode, it will shortly again come again. All the other detection systems we had here inside the building were still in properly function mode. If there would have been a problem, for example, by a fire inside the first floor, the smoke detection system would have given alarm to the control unit. You would have seen it, everything, that's it. But because there wasn't any fire alarm, the security called at 1634 the maintenance company, Fessmann, to come to the site and to check the reasons for this false alarm. At 5:02 p.m., the representative of Fessmann, the technician, arrived at the site. He got a short resume from the security, and at 5:05 he began to check the system. First he separated the signals coming from the pump station, so he could reset the control unit in standby mode. And afterwards, he went to the switchboard room. He put off the smoke exhaustion system. Then he went to the server room. He resetted the automatic voice alarm system. And last not least, he went to the pump station. Of course, when he came to the underground, from the pump station, outside, there's a loud sprinkler bell ringing. He heard it. He went into the pump station, and he was switching off the water pump. At this time, people came to him, informing him that at an HVAC room and ventilation room, which is located nearby in the basement under the residential building, that there is water coming out. So he went to this room to check where the water is coming. Noticed it came from the drain. That means from the bottom, so it had obviously nothing to do with the fire alarm system, with the sprinkler system. And when he was on his way back to the security to inform about the reasons he saw and to inform about next steps, maybe. Then he saw an open fire hose cabinet in the building, in the underground. And that was at 1744. At this time, the collapse of the roof began. That was the first collapse. 1 hour 20 later, the second roof of the collapse began. So it's interesting to know what is the reason for the activation of the fire alarm system giving a false alarm at this time. As I already told, the fire hoses and the sprinklers in the underground and the pipes in the underground were of dry system. They were filled with compressed air. And one possibility could be that there is a small leakage inside a pipe system of the fire hoses. So the air pressure is dismounting, and when the pressure is low enough, then a valve would open. But we've got here a ring system, and we have got here an air compressor who is supplying this system. And even if the air compressor would be defect, so what happens if there is a leakage, a small leakage? So the air pressure isn't dismounting only on a special area, but is dismounting in the whole ring system. So both clappers would have been opened, both valves 5 and 6. But in reality, it was only valve 6 which has opened. So after analyzing the situation, we came to the conclusion that this option appears unlikely. Other possibility, we saw that there's an open fire hose cabinet, and we see that there's some disruption here. So there could be the possibility that someone dismounted the rope of the fire hose from the valve, opened the valve, perhaps to get water, could be a possibility, but that's a speculation, we don't know. Opened the valve, and of course, it was a fast, very fast dismounting of air pressure. And this cabinet is nearer at valve 6 than valve 5. So valve 6 opened and gave the alarm here. So disturbed by the bell, the person got frightened, closed immediately the valve, remounted the fire hose rope, and vanished away. For us, that's the most plausible version and the conclusion for this fire alarm, which wasn't a real one, but a false one. So I give now to my colleague, Mr. Fuad, to explain the reasons for the collapse of the roof.
Yes. Dear ladies and gentlemen, we investigated the collapse of the roof from the structural point of view, and I would like to shortly introduce you the results of our investigation. Firstly, I would like to explain or show you the construction of the roof. It is made of a concrete slab which is supported on steel trusses which are about 16 meters long. These trusses were divided in 2 parts, as we were told, for transportation reasons. And these 2 parts were connected inside by screwing them in the middle in this region and in this region. Our investigation had shown, or our investigation on site has shown, that the state of the steel structures, even after collapse, is good. The main problem, or the major problem, was these connection points between the 2 halves of the structural steel truss. Our calculation had showed that this connection of the steel truss was under the loads during the incident was about 2 times higher than the capacity of the joints, or it means that it was overloaded by 2 times without considering any partial factors of safety. If we compare it with the capacity needed, considering the partial factors of safety, it is even more overloaded. That is the reason why the screws at this point, the screws at this point failed firstly, and consequently all other connections which are here were overloaded and failed afterwards, so that we had the total collapse of the construction. This happened very rapidly, so that we can say that the collapse was instantaneously. Our calculations showed that the deformation of the structure just before failure was so small that it couldn't have been seen, and we come to the conclusion that the failure was without any visual or acoustic prior warning. If I'm speaking about acoustic prior warning, I mean that there were no sound or acoustic signals due to cracking or something else like that. Another point which I want to show you is the fact why there was a lag in time or different times during the failure. There was an unwanted connection between the steel structure and the concrete slabs over it due to the composite action of these bars, which you see here, which are welded on the top of the steel structure. They were connected with the concrete, and that led unwantedly to an increase in the structural capacity. Due to the nature of this connection, they fail with time due to creep factors and internal cracking and internal damaging, which explains this time-dependent or time difference in the failure of the construction. I can summarize that the collapse of the roofs was mainly due to the tensile failure of the screws of these assembly joints at the middle of the steel trusses, and the reason for this failure is an underdimensioning in the statical calculation, which are not being done right. So we can say that the main issue of the failure is the assembly joints. They were too small and too few. Thank you.
So now we are continuing with the last part, the discussion if there would have been possible interconnections between the activation of the fire alarm system and the collapse of the roof. One question we had to surface was, could possible movements of the building structure or alterations in the building structure before collapse of the roof activate the fire alarm system? Because we've got here 2 situations, and naturally people are asking for this. Why was there a fire alarm and we had here a collapse of the roof? So is there any correlation? We can say no, it could not. And why it could not? We've got a fire detection system, not a movement detection system. Fire detection system, an automatic with smoke detectors, as you probably use it in your homes, for example, but in another style. What's happening inside? If a loose contact, if a break of wires wouldn't cause any fire alarm, it just would send a failure to the control unit. Look, there's a mistake, please check it, change it, but not a fire alarm. Fire alarm by such smoke detectors is only caused in such way. We've got here infrared LED, which sends constantly light to a chamber cover. And normally the photodiode light receptor doesn't get any signal from there. only if smoke is coming inside such detector, the particles reflect the beamed light, and of course changing of direction by these particles, the photodiode light receptor gets a signal, and in this case a fire alarm is sent to the control unit. That's one part. The other part, we've got here a sprinkler system. I explained that there are pipes mounted under the roof, but these pipes aren't the pipes for the fire hoses line 5 and 6 where the alarm came from, but there are the pipes from the lines 3 and 4. And even if there would be a leakage inside a wet system, you can be sure that you see that there's a problem immediately, because a sprinkler which is breaking is opening a valve, and such a sprinkler at 1 bar pressure exceeds about 80 liters per minute out on water downwards. And 80 liters is a lot of water. As you can imagine, in a minute, it's half a bath tube. So, again, if there would be a leakage, you would have seen it. If there would have been a leakage of line 3-4, we had got the signal from line 3 and 4, but not from line 6. So that's not possible. There was no intercorrelation. Could construction work do anything to the shopping center? Could it activate fire? So it could not. The reason is quite the same. We've still got the fire alarm only from line 5 and 6, and normal work on a roof does nothing to mounted pipes under a roof. Nothing happens there. Overall conclusions at the end. In all the time, the main fire detecting systems were in full operational mode. That we can see because we got a false fire alarm, and even after restarting or the system, it was still in work. There's no correlation between the collapse of the roof because a fire detecting system isn't designed to anything like this. And the reason for the fire alarm was definitely false alarm, maybe caused or probably caused by personal interference. And both situations, this was mischanged, it was a coincidence. Thank you very much.
Thank you, gentlemen. Actually, I'm very appreciative about the direct and not that diplomatic approach. I expected more like, we think that this and this could have happened and so, but I see that you're really sure what you're talking about, and it's based on your engineering experience and background. So, do we have any questions here in the room? This is a sort of hot topic in a way. So, yeah. Do we have a mic here for the audience? Yes. Please say who you are and.
Hello, my name is Priedaines Str. I'm working with construction product evaluation and the conformity assessments. So basically, it's not like a question, but this case actually showed that the good practice of our engineers is lacking behind. They saw that instead of tension joint was created a compression joint, and it caused a problem.
Yeah, indeed, it was a tension joint, but it was dimensioned in a not correct way. It was under-dimensioned, yes. That's the main reason. The number of the screws and the screws type was not correct. And the geometry was not correct. Right.
So I see you both agree
We
on the same thing.
That is correct, but
Any
I
other?
wouldn't call it a compression joint.
Yes, normally intention we build a different type.
Yeah, that is correct. That is correct. That's what I mean.
All right. So any other comments, quick questions? If no, let's put your hands together. Thank you, gentlemen, for this.
Thank you very much.